All right, section 4.4. This is the last one of chapter 4. So we are going to now talk about how atoms can actually be broken apart and what happens with them. You guys have heard about radioactive decay, radioactivity, and you think it's all very bad stuff. So what we need to do is actually define what this thing is, what happens, where it comes from, and how do chemists actually use it. So what it is, it's got unstable nuclei. So in the middle, your protons and your neutrons. The middle, that nucleus, is going to be unstable somehow. Something's going to happen to it, and it's a change in the nucleus. So we got 3 different definitions here for you. We got radioactive decay, which is a spontaneous process in which unstable nuclei lose energy by emitting radiation. You've got radiation, so what is it that we just talked about above? It's rays and particles, which we have alpha and beta particles, and gamma rays that are emitted by radioactive materials. And then you've got your nuclear reaction, a reaction that involves the change in the nucleus of the atom. So we've got these definitions. Let's see how we can actually use them. Here's your 3 types. We've got alpha, beta, and gamma. In your alpha particle, we're going to take Pu. We're going to take that element, which has a mass of 240 and an atomic number of 94. What we're going to do is use its full chemical symbol, and we're going to see what actually happens when we alpha decay it. Now, what we have, though, is a decay. Alpha particles are going to come out of the nucleus. And then we can see what element is left over after that alpha particle is gone. Now, what you'll notice is the alpha particle down in the corner of the picture, we actually have a mass. It has 4 and 2, a mass of 4. The 2 is the number of protons. Well, if you look on your periodic table, the element that has 2 protons is a helium atom. So alpha decay is actually a helium atom being given off by the nucleus of an element.
So let's look at this alpha decay. Pu, the symbol is Pu. So what is the element actually called? Look on your periodic table. Look for your atomic number of 94. You'll find it is plutonium. So plutonium is decaying into U, which is uranium, and this alpha particle, or helium.
All right.
Okay, so the reactant in this problem would be plutonium. Your products are going to be uranium and helium.
So once we got a 4 and a 2 coming out with the alpha particle, so that's where we got the uranium 236 and 92 from?
Yes, and we'll go through some of those problems a little bit later.
All right. So should we talk beta?
Sure.
All right. Beta is a minus. This one's a minus decay. There's a couple different beta decays. Really all you need to know is not that it's a minus, that it's a beta. From that nucleus, you're actually going to give off a beta particle. Now, a beta particle is a 0, a -1. Now, in this case, it actually has an E written. We will probably in class be using the B symbol that you see in the beginning, that B minus. We're going to use the B, but we're going to use the mass of 0 and a -1 charge. So once you take that out of the nucleus, out of the center of the atom, you're left with the same mass that you started with. But you actually are going to gain a proton because you took out a piece of the neutron and you're moving things around. So what we've got from the beginning, you've got your Ra, your radon, 228 and 88. You're going to take out a beta particle, which is a 0 -1. And you're going to be left with 89 and 228 AC. You want to talk
Actinium.
Okay. You want to talk gamma?
Sure.
Okay.
Gamma decay, there goes the lights again. Gamma decay, you're actually not getting a particle out like you do with alpha and beta. Instead, you're just getting a large amount of energy. So, gamma is this funny looking Y symbol down there. You're going to start with plutonium. Notice it has a little star on it. Now you have a gamma decay. Notice the little wavy line underneath it. That means energy is coming out of the actual plutonium atom. At the end, you still have plutonium, but all that's happened now is you've released a bunch of energy. So it's high energy and electromagnetic waves. That's what the little squiggly line is. So gamma decay is actually the easiest one. Somehow it trips up a lot of students, though, because they don't know what to do with a gamma decay. You are going to have the same element in the beginning as you do in the end.
All right. So let's talk what happens when they're given off. So if we take a charged, 2 charged plates, we have a positive charge at the top, and we've got a negative charge at the bottom. And we're going to shoot all 3 particles, well, 2 particles and a ray, through these two plates, and we're going to see what happens. Well, your beta is going towards the top, which means that it is going towards the positive. Well, a beta is a negatively charged particle. If you're negatively charged, you're going to go towards the positive because, what about our charges?
Opposites attract.
Yes, our opposites attract. We've got a positive plate, a negative particle, and that's why it's going to bend up.
Mhm.
Your alpha has a much larger curve because it's heavier. It has a mass of 4, and it has an overall charge of positive. So it's going to bend towards the positive plate, or towards the negative plate at the bottom because it is a positive particle. You'll see gamma going straight through because it has no charge, it has no mass, it's just energy. So it's going to travel straight through. Now at the bottom, we've got how these particles of radiation will actually affect you and how it can harm you. The alpha particle, because it's so heavy, has a mass of 4, it's a big particle. You will actually, as a person, stop alpha particles from passing through you. You will absorb them. Beta particles will travel through you and be stopped by aluminum plate. And gamma, the energy, high energy, will travel through you, through aluminum, and can be stopped by very thick lead. All right? So that's how the alpha and beta and gamma particles will travel through different things, and what you'll hear about different radiations and how far away you need to get and everything else. So let's do some decay problems.
Okay.
Mrs. Kelly is going to write for us,
Yep.
and we're going to alpha decay radium-226. Now you see radium-226. The 226 is your mass, so you don't need to look on your periodic table for that one. What you need to do is use your full chemical symbol, and you're going to do your,
Oh no.
oh, it's on the arrow, that's why. You'll have to,
Second.
oh,
Did I do
there you go.
this?
Yep, pointer and pen.
Okay. Let's
All
go
right,
back.
so
Okay, radium.
we're going to use our radium. We're going to write our full
It's
chemical
RA.
symbol. Yep.
Okay.
And 226 is the mass. That's going to go on the top. We're going to look on our periodic table, and we're going to look up our radium, and we find it to be 88 for the atomic number, which is going to go on the bottom.
Yep.
Now we're going to alpha decay, which means alpha is given off as one of our products.
Right.
So radium is our reactant. Now we're going to have products. Alpha is one of them. You could write it as the alpha with the letter A with a mass of 4 and the charge of 2. Or you could write it underneath maybe. Should we show them how to do the helium?
Sure.
We could do also the He with a 4 or 2. You can do that either way.
Either one. And on your cheat sheet, you have
cheat
alpha,
sheet.
beta, and gamma
They're all
written. Okay, so when you take your tests or when you're working on your labs or your worksheets, make sure you're looking at your cheat sheet.
front side in kind of the underneath the middle, but still in the center. Okay. All right, so now we've got the alpha coming out. We need to know what's left over. So we have to actually do some subtraction. All right. We took 4 away from the mass.
Yep.
So instead of 226, we're going to be left with 222.
Okay. And now 88 minus 2. That'll give you 86.
And 86, you're going to look on your periodic table. You're going to go down and around and look through and see if you can find 86. And 86 is found over here, and it is radon, Rn.
Okay. So notice you changed your atomic number. You have changed your element.
All right, that's an alpha decay.
Okay.
Let's try a beta. We're going to beta decay carbon-14. So we're going to write the chemical symbol. Now, again, carbon-14 means 14 is the mass. If you look on your periodic table, you're going to find it mass is 12. You don't want to use 12, you want to use the 14. She knew that the atomic number was 6, so
And
she
you will
wrote that
too.
down. Yeah, let's hope so. And we're going to beta decay. Now, beta is a 0.
There's a
Ah,
funny
there's a
B.
B. 0 is the mass because there's no mass, and it has a -1
Oh,
charge. Just click, yeah. There you go.
Okay.
Negative
-1.
All right. So if we've got a -1 coming off, and we're going to subtract 6 minus a -1, we actually get a
7.
7.
Okay.
So our atomic number is 7. Our mass stays the same as 14. So we're going to look up on our periodic table. We're going to find 7. Right next to carbon, we got nitrogen.
And you will learn all of these, so you won't have to keep looking at your periodic table. It will get you a lot easier.
I know you're thrilled. All right, we're going to alpha and gamma decay uranium-238.
Okay.
So,
Uranium 238.
there we go. 92 is its atomic number.
Okay.
And alpha and gamma, what we're going to do is we're going to alpha decay first. So let's figure out our alpha. We got 4 and 2. And then what are we going to be left with? We do our subtraction. 238 minus 4 leaves you 234. And 92 minus 2 is 90. We can all do our basic math skills. So we're going to look up 90 on our periodic table, and we're going to find it to be TH, thorium.
Okay. Now, why do we leave gamma to the end?
Because gamma has no mass, it has no charge, so it doesn't make a difference on what element is left over. It just has to be on there to show that it was given off. So we have gamma, and we can write a 0, 0 for the mass and for the proton number, because it doesn't have any of those. So we still show that it has nothing by using 0, 0, and we have to show that gamma was given off because it is energy. It was used, it's there. So that's it though.
Okay, so alpha, beta, gamma, we'll go over them in class. But again, they are on your cheat sheet, and once you know how to do them, they're very easy to do. Make sure beta you're adding because you're subtracting a negative, which turns into adding.
All right, ready? The very last part of this section, we've got for you some more videos for you to watch. It's really short ones off of YouTube. The first one is on the radiation from a nuclear power plant, because a lot of times people...
Power plant.
We're using a power plant. Thank you. The power plant, you know, people are scared of it. You don't know why it's given off, and everybody, the news takes over and says how bad it is, or the Japan one with the earthquake a few years ago. So this video explains what radiation is, what can happen, and everything else. The other big question I usually get in class, and I don't know, Miss Kelly, you might too.
I get it all the time.
Well, how do we use plutonium and uranium in atomic and nuclear bombs? So what we did is we put in a little video on the explanation for the little boy and also the fat man. So the little boy was made of uranium, and fat man was actually made of plutonium and uranium. So those are the two nuclear bombs, and it kind of tells you how they will work. Okay? See you later!